Cook here. Welcome to session number 21 of the Mastering Mandelbulb 3D Formulas tutorial series. I wanted to do something a little interesting here in this session. Not that nothing's interesting about the Mandelbulb 3D application, but this is something I think probably will help you out a little bit. It's a process that I had to go through too, early on to kind of figure out what is this Mandelbulb? What is this all about? And basically, the Mandelbulb is a Mandelbrot that has had that has had an addition to its formula, all right? And that addition is very often referred to as kind of a spherical coordinate. And so basically it will take the flat Mandelbrot, the 2D Mandelbrot, and add a third dimension to it to make it 3D, to make it a bulb. All right, let me see if I can demonstrate this for you. Now, the easiest thing to do is to go up on Wikipedia, and let's open up that. There we go. So you'll notice here in the Wikipedia, it is completely describing the Mandelbrot. Of course, now the Mandelbrot is the 2D representation, all right? And if you look down through this article, what you're going to find is down in here. Okay, here we go, right there. Okay, this formula right here. Let me see if I can, there we go. All right, that formula right there, that represents the Mandelbrot set. And basically what this formula is doing, now I'm not getting into all the math, but I'm just giving you enough so I can kind of demonstrate something over here in the Mandelbulb 3D. Basically what this is doing is, this is an equation, a formula, that will run, and all of the values of this equation that do not escape to infinity will be represented by a point. Okay, now, and these points are the visuals that we see. These are points that did not escape to infinity. Let's get back over the top here where we get a little bit better picture of the Mandelbrot set. Okay, so all of the pixels that are in the black there, all right, are points which stayed within that didn't escape, okay? And so those are points. Now, that whole process, that equation, works exactly the same way in the Mandelbulb 3D application. The difference is that there is another coordinate that's added that the Mandelbrot set does not have. All right, so by adding this additional coordinate, we actually take this Mandelbrot set and make it into a 3D. Let me see if I can give you a little bit better appreciation visually as to how this thing plays out. Now let's turn our attention back to the Mandelbulb 3D application. I'm going to leave the web browser up so that you can see the picture of the Mandelbrot. Okay. Now I have here integer power. This is exactly what happens when you open the Mandelbulb 3D application. You get this default, which is integer power. It has two properties to it. One is called integer power, and the other called is Z multiplier. Okay. Now, that is what we're looking at right here. This is a Mandelbrot set that has been made 3D. In other words, it's become a bulb. All right? All right, now, I'm going to do a couple things here. first of all, in order for you to replicate this, do a reset, and then that will put you back to integer power with these two properties defaulted. You got to do one other thing now in order to see what we're trying to illustrate. Go up to position, drop that down, and hit reset. All right, the position tab, reset. All right, and recalculate. We can close this position now. We don't need it. Okay. This is still the Mandelbrot with the 3D, the spherical coordinates applied to it. Now let's do an interesting test here. I'm going to take this integer power here and I'm going to change it from 8 to 1. All right, that's a 1 now. And I got to recalculate. Now watch the visual. All right, I have something very similar to our Mandelbrot set that we see here in Wikipedia. Okay, all right. Let's go one step further here now. If I'm on the Mandelbulb3D main page. Down here at the bottom, I do have some controls where I can move this thing around a bit. This one right here that I'm hovering over, all right, that gives me the ability to move the fractal object left and right, up and down. So I'm going to click on that. I come on and I hold my left mouse button on, and I can drag it over. Now I'm going to let go of my mouse button, and look what I got. Now this is very interesting because I think what's going on here is when I have moved this object, it didn't render out. All right, I'm not really sure if the application just was never finished and it didn't recalculate automatically for me. I mean, I moved it, but it didn't recalculate. But whatever the reasons for this, we are seeing here the Mandelbrot set. In other words, we are seeing a Mandelbulb that has not had the spherical coordinates applied to it and therefore is not a 3D fractal yet. All right, that is just some sort of a weird 2D preview of the fractal object that we just moved. Okay, let me recalculate now. Calculate 3D. All right, now I've moved and now it has applied the properties, and now I have a 3D Mandelbrot. In other words, I now have a Mandelbulb. All right. We've got a couple more minutes left of this session, so let's just kind of play with this. I am going to change this to, I don't know, 5. Change it to 5, recalculate. Now that is my Mandelbrot that only has half of the spherical coordinate value that's been applied. Let's try our little trick here, and we're going to try moving this, and so we can kind of force a 3D, a 2D. So that's what we get. So look, let's do this. Let's do this. Here's the 8, and that is a fully formed Mandelbulb 3D fractal object. Let's try moving it here and get the preview. All right. All right. Now that's with the full value of the spherical coordinate applied. Now let's knock this all the way down to 1. So basically, we're not going to be applying a spherical coordinate. All right, so we're not going to get a bulb anymore. We're going to get something more flat. So let's calculate that. All right, let's try moving again. Try our little trick here. There's our little unrendered preview, and it's very, very close. That is a Mandelbrot. That's a Mandelbrot without the 3D coordinate applied, or it's only 1 if I recalculate. What if I put that integer power down to 0, recalculate? Okay, not much different, but let's try the move technique again. That's pretty much the same. All right. So what I wanted to show you here in this session was an illustration, an example of how we get this 3D Mandelbrot, which we call a Mandelbulb. And it is simply, and I say simply because it's fairly easy to understand, but I'm sure that the original people that dreamed all this up really had to really think about this and understand the math thoroughly in order to be able to realize that what you can do is you can take the standard Mandelbrot formula, apply another element to it, and blow it out to become a three-dimensional Mandelbrot. All right? So we're going to move on in the upcoming sessions. We're going to get back to our formulas. We're going to start talking about the hybrid modes. Okay, we're getting in deep. But I wanted to take one session here and give you a pretty good idea how this Mandelbulb3D takes the Mandelbrot set, applies a spherical coordinate to it to give us a Mandelbulb, or a three-dimensional Mandelbrot. And this illustrates how it works. Okay? So I hope that was helpful. Hey, I'll see you in the next session. We'll continue this fun. I'll see you there.